Hello, in this video I'm going to teach you how to calculate definite integrals using integration by substitution. And so for this, it's probably going to be useful if you can calculate an indefinite integral using this method. If you can't, I've linked my video on that in the description, so you can go and watch that and then come back and see this. So I'm going to timestamp each part of the video so you can just skip through to the part that you want to see. And we'll start off with the first example. So we want to integrate between the limits of 2 and 4, so that's why it's a definite integral. We have a limit, so integrate between 2 and 4 of that function of x there with respect to x. And the first step is we just want to find part of this to set equal to u for our substitution. And a good rule is if we've got something in brackets, we're going to set that equal to u. Okay, so I'm going to set this part here, 2x squared plus 3 equal to u. And you can kind of see when I take the derivative of that, I'll be left with an x that will cancel with that one there, but we'll see that in a second. So I'm going to set u equal to 2x squared plus 3. And from here, we're then going to take the derivative of u with respect to x. And if we do that, we get du by dx is just equal to 4x. And we can then treat this like a fraction, and we can rearrange it to make dx the subject, because if we've done that, then we can substitute it in there for our dx. So to do that, that's pretty easy. We're going to multiply both sides by dx, and then divide both sides by 4x. And if we do that, we would get that du divided by 4x is equal to dx. So from here, I'm just going to substitute everything I know into the original integral. And for now, I'm actually going to leave the limits alone. I'm not even going to write them in, because we'll change them in a second, because it's pretty easy to do. So we've got the integral of x multiplied by, well, 2x squared plus 3 is equal to u. So we've got x multiplied by u squared. And we have that dx is equal to du divided by 4x. So we could write in du divided by 4x there. And you'll see that these x's cancel out, and now we have an integral in terms of u with respect to u, which is what we wanted with the substitution. The problem is, if we look at our original limits, this 2 and 4, that's when we're integrating with respect to x, okay? And so we need to change them to make them for when we're integrating with respect to u. And this is really easy to do because we've got this little equation or formula here for u, and it says that u is equal to 2x squared plus 3. So I'm just going to substitute one at a time, the lower limit and the upper limit into that to find them in terms of u. So we've got that u is equal to, well, when I substitute in the lower limit first, okay, so when x is equal to 2, we have u is equal to 2 multiplied by 2 squared plus 3. And so if we simplify that, we've got 2 squared is 4, so 2 multiplied by 4 is 8, 8 plus 3 is 11, so that's my lower limit. And I'm going to do the same for the upper limit, which is 4, so we get that u is equal to 2 multiplied by 4 squared plus 3. 4 squared is 16, 16 multiplied by 2 is 32, plus 3 gives us 35, like this. And I'm just going to rewrite this integral just to make it look a bit nicer. So I'm actually going to pull out this divided by 4, this 1/4 to the front, because it's a constant, so I can move it to the front of the integral. So now we have 1/4 multiplied by the integral between 11 and 35 of u squared with respect to u, which is actually pretty easy to calculate. So remember, when we're integrating, we add 1 to the power, divide by the new power. So we're going to get that 1/4 multiplied by, well, u cubed divided by 3 between the limits of 11 and 35. So when we're calculating a definite integral like this, we're going to substitute in the upper limit and then subtract what happens when we substitute in the lower limit. So we've got 1/4 multiplied by 35 cubed divided by 3, subtract 11 cubed divided by 3. And I obviously can't do that in my head, so I'm going to quickly use a calculator. So we've got 35 cubed divided by 3, subtract 11 cubed divided by 3. And if we work that out, we get quite a nice answer actually. We get 3,462 as an answer to our integral. Let's now look at a second example, okay, where we want to integrate between the limits of 0 and 2 pi of sine x cos squared x with respect to x. And so the first step is we're going to find what part of this we're going to set equal to u. And if we sort of think about it and think about the process we're going to do, if I were to set cos equal to u, when I differentiate it, I would get du divided by negative sine of x. And you can see that would cancel out with this sine of x here, okay? So I'm obviously now going to set u equal to cos of x. Now from here, we're going to do the same steps as before. We're going to calculate du by dx. And if we do that, we get that, well, cos of x differentiates to negative sine of x. And then we can rearrange this to make dx the subject, and we get du divided by negative sine of x is equal to dx. Same process again, I'm going to substitute what I know in. So we now have the integral, okay, between, well, I'll work out the limits in a second, of sine of x multiplied by u squared, so multiplied by u squared with respect to u divided by negative sine of x. And obviously these sine x's are going to cancel out, and we're left with the integral of u squared with respect to u divided by negative 1. Let's now calculate our new limits, okay, so obviously working in terms of radians here. So we have that u is equal to cos of 0. And you could use your calculator if you want, or you could think about, you might just know the values, or you could just see what the graph looks like. So I'll try and sketch it. If we had 1 and negative 1, cos of x, that's terrible, but it looks something like that, yeah, it's like a, I don't know, that kind of shape. So at 0, it's going to be equal to 1, so cos of 0 is equal to 1. And if we work it out when it's 2 pi, we have cos of 2 pi, and that would be at this point here, so that would also be equal to 1, okay? And so we're calculating now the integral, let me write in the limits, between 1 and 1 of u squared with respect to u, and this negative 1 here on the denominator is a constant. I'm going to pull it out to the front of my integral. So we'll have negative integral between 1 and 1 of u squared with respect to u. Now I will integrate it just to show you, but if you think about it, if we're integrating between 1 and 1, the limits are the same, like we're obviously going to get an answer of 0, but if we wanted to actually calculate this, we could. So we add 1 to the power, divide by the new power, and substitute them in. So we've got negative 1/3, subtract 1/3, and so we get an answer of 0. So hopefully this video was useful. So like, subscribe and share if it was, and go over to my channel and check out all of my other maths tutorials. Thanks for watching.